Good morning, scholars. Welcome back to the Kemet Maasai Academy. This morning we're looking at angles. We're going to be estimating angles. Alright, so an angle is formed where two line segments or two lines meet each other. Automatically, two angles are formed, actually, right? But usually we're focusing on one of the angles that maybe is within a shape or maybe just within the particular space that we're focusing on. But just bear in mind, whenever one angle is formed, another angle is automatically formed, at least one other angle. We might refer to the angle that we're focusing on as the interior angle, and the other one would be the exterior angle. But just bear in mind there is another angle formed. Once two lines converge, there are automatically two angles at least that are formed. So angles are measured in degrees. So for example, 54 degrees, that little circle, tiny circle that we put to the top right hand of the number, that's the degree symbol, and that's the unit we use when we're measuring angles. A protractor is used to measure angles. So if we want to get an accurate reading of the angle, the space, the degree of space between two lines, we use this instrument, which is a protractor, right, to measure the angle. So this is what it looks like as I sketched. It's not perfect, but typically what it looks like. So it's in degrees from 0 to 180 degrees. And it's actually, the measurements run from left to right and right to left, because sometimes the angles are turned towards the right, like in this case, it's turned towards the right. So we would start measuring from this 0 here up this way. Sometimes the angles are turned towards the left. This is turned towards the left, that's turned towards the left, this is turned towards the left. So for those angles, if we're using the protractor, we would start counting from the 0 on the outside of the protractor and go that way. In either case, the 90 degree is dead center. You know, a half of 180 degrees is 90 degrees. So this straight line, when we're using the protractor, this straight line here, we would line it up with the baseline of the angle that we're measuring. The point here, that T right there in the middle, we would line that up with the vertex where the two lines meet, and that's where we're going to start measuring our angle. And then if it's turned to the right, we take our measurement from 0 that way. If it's turned to the left, we take our measurement from 0 and read that way. Alright, so here's the protractor. Hopefully you can see it. It's transparent, and usually the protractors are transparent because we want to be able to line up the baseline with the base of the angle that we're measuring. We also want to line up that T in the middle with the vertex of the angle that we're measuring, and we want to be able to take our readings along the edge, whether from the right or from the left. So for example, if we're measuring this angle, we would line up the vertex here with the T in the middle, right there, and line up the baseline with the baseline of the protractor. Since this angle is turned to the right, we would start reading from the inside 0, that one, and take our measurement and stop where the angle stops and get our reading. But today we're not going to be using the protractor. We're not going to get accurate angles. We're going to be estimating angles and saying whether they are acute, obtuse, reflex, right, straight, and so on. So let's look at the definition then of what these angles are. So the right angle is formed when two lines are perpendicular to each other. We have a straight line, a vertical line meeting a straight horizontal line, they meet at a right angle, and the measurement of that angle is 90 degrees. So wherever you see two lines and you see this box here, it means that's a right angle and the measurement is 90 degrees. If the angle is less than 90 degrees, we say it is acute. If it is exactly on a straight line, whether it's a straight horizontal line or a straight vertical line or a straight oblique line, so we could put it this way. That's a 180 degree. That's a 180 degree angle. It doesn't matter the inclination. Angles on a straight line add up to 180 degrees. If it is more than 90, so remember the 90 would have come down like that. So the 90 would have been that. So this is more than 90, and the 180 would have gone across that way. So this angle is more than 90, but is less than 180. Don't reach the 180 yet. Same for this. The 90 degrees would have taken it here, and the 180 would have carried it all the way across here. So this angle formed between these two lines it passed the 90, but it don't yet reach the 180. So those angles, so for the angle is greater than 90, less than 180, we say it is obtuse. And if it is greater than 180, but less than 360 degrees, 360 would have been the full circle. The full circle, 360. The 180 would have been that. So the angle here, this full angle here, is more than the 180, but it don't quite reach the complete circle, the complete 360 degrees. So we say that it's a reflex angle. So we're going to use these clues to estimate we're going to use these clues to estimate these angles. Now, we know that a right angle is 90 degrees. So halfway through that angle would be 45 degrees. Half of 90 is 45, right? And if we divided that right angle into three equal parts, this one part would be 30 degrees. So that's roughly what a 30-degree angle looks like. And two 30-degree angles would be 60 degrees. So this is roughly what a 60-degree angle looks like. Now if this is 180, and we know that this part of it is 90, we can divide the other part into any number of segments we want, that we want to estimate. So we'd add the 90 plus 30, that would be a 120, plus 30, 150, and so on, to estimate. So what we're going to do for these angles that we're being asked to estimate, we're going to just draw our little quadrant where necessary to estimate the 90 degrees, the 180 degrees, whichever number we need to estimate, and so we can make a good estimate of the angle and say whether it is acute, obtuse, or reflex. Alright, so for this angle, it's turned to the right. We know that the 90 degrees would have gone straight down there. Okay, so this looks, and I think halfway would have been about there. So it's not quite 45 degrees. It's a little less than 45 degrees. So I'm going to estimate it at about 40 degrees, and I'm going to say it's an acute angle. Alright, it's acute, less than 90 degrees. For this one, we're sketching in where 90 would have been. Alright. This looks like, alright, if we divided up the 90 like this into the three parts, this would be just a little less than it's just a little less than the 30 degrees. You see that? If we divided up the 90 degrees into 3 equal parts. So I'm going to estimate and say this is about 25 degrees, and once it's less than 90, it's acute. Alright, now for this angle, it has passed the 90 degree. It has passed the 90 degree. It's not yet 180. And it's this part from the 90 to here seems like almost it's not fully half. So it looks like 1/3 of the other 90. So this is 90. We know this part is 90. And then this part represents 30 degrees, which is 1/3 of the other quadrant. So that's 90 plus 30. So I'm going to estimate that at 120 degrees. And that is an obtuse angle. Because once it's more than 90, less than 180, it is obtuse. Or how about this one? Or the 90 degree would have come straight down like that. This looks like pretty much halfway. So I'm going to say that's a 45 degree angle, and we know that's acute. Or how about this angle here? It's way past the 90 degrees. This is 90 degrees here. Not yet 180. Looks like halfway between the 90 and 180. So that would be, over here is 90. And this would be halfway, that's 45. So I'm going to estimate this as 135 degrees. And that is obtuse. Or how about this one? So it's past 180, long time. That would have been the 180. It's also past the other quadrant, which would have taken it 90 more degrees, that's 270. And then it looks 1/3 of the fourth quadrant. So that's 30 degrees into the fourth quadrant. So that's 180 plus the 90 for the third quadrant, plus the 30 from the fourth quadrant. 9 and 3, 12 and 8, 20. So that's 300. So I'm going to estimate that this is 300 degrees, and that's definitely a reflex angle. So I just put in my little lines. I know this would have been my 180 line. So it's past 180. This would have been another 90 degree here, which would make it to 270. That's the third quadrant. And this angle here seems like 1/3 of the fourth quadrant. So that's 180 plus 90 plus 30. Definitely a reflex angle. How about this one? Alright, it's past the 180. It passed the 270. And this seems like about 60 degrees. Remember the 60 degree angle? 2/3 of the quadrant. This seems like about 60 degrees. So that's 180 plus the 90 plus the 60. 9 and 8, 17 and 6, 23. 330. So I'm going to estimate this as 330 degrees, and that's a reflex angle. So when we're estimating angles, we just cut up our quadrants, whether it's a 90 degree, the first quadrant, and we estimate to see is it halfway or almost halfway, or is it 1/3, in which case it will be 30 degrees, or is it closer to the two parts out of that quadrant, 60 degrees? How close is it? Is it closer to the 30 or closer to the 60, or exactly halfway, 45? And then we can add that to whatever we know already. So we can draw in our 180 degrees if we pass that, and then estimate the rest and add it back to it. Right? So that's how we estimate angles. And of course we know our faithful protractor is for when we want to be exact. We want to be accurate in measuring our degrees. The space between two lines is an angle, and we measure that in degrees using this humble but beautiful and precise instrument called a protractor. Alright, so if you have benefited from this video, just drop a line to say thank you, miss, and share the video so other students may benefit. Share it with your cousins, your friends, your siblings. Even though they're in the home with you, share the video. Almost everybody has a device nowadays, so share it to them. Share it to your classmates. And if you want me to do a video on any topic that you haven't seen in the catalog, just let me know. You know that I'll do it for you. If you haven't subscribed as yet, please subscribe and click the bell so you'll be notified as soon as a new video comes out. My scholars, I hope you keep practicing, and I hope you fall more and more in love with this beautiful subject, mathematics. I'll see you in the next video.